Hello, welcome to Civ1299, a graduate course taught at the Department of Civil Engineering at the University of Toronto, related to the business of civil engineering knowledge. This is Module 3 that relates to defining the knowledge economy. The first question is, what is knowledge? Initially in the 60s, 70s, and early 80s, it was clearly to everyone that it is the use of information technology such as computers. But then as globalization took place and the internet became used widely, processes establishing a work process that is more smarter and efficient than another process became an interesting and more important aspect. We now, in an era, especially with the social media and the crowdsourcing, where people are the most important asset in generating knowledge, and the idea of an organization becoming a learning organization to generate knowledge and teach its employees to generate and use more knowledge is becoming important. And the whole idea is now no one organization can control all the knowledge, so you have to partner with other like-minded organizations to exchange knowledge. As you can see, it's moving from easy to tough, and from clearly defined such as IT code to ill-defined things as the knowledge in the minds of people. And as you can see also, we have more of an interrelationship between organizations and a focus on the business of exchanging and generating and even selling the knowledge. We discussed in the early part of the course that for that you need to have a model of the flow of data and the relationship between them. So this is one small part of the data flows, material flows in the apparel industry. It's based on a knowledge model which explained what are the processes, what are the input data, what is the output, and who should do what at when, and what are the qualification of these people. That mix of data, IT, process management, and roles and responsibilities is the current way of exposing or externalizing the knowledge in business. The collaboration across different organizations to produce knowledge is also becoming a cutting-edge part of the competitiveness. This is GlaxoSmithKline innovation outsourcing map. As you can see, they know areas where there is need for research, innovation, development, and technology, and they partner with a variety of companies, as you see them on the right. And each one of them has a technical focus that integrates with another, and the main role of GlaxoSmithKline is to exploit and connect all of these to come up with new products. One thing that we need to consider in the beginning, which is the role of cloud computing. It is related to three elements: the outsourcing of IT, the concept of software as a service, and software platforms. The first type of cloud computing is the most obvious, which is the infrastructure as a service, whereby instead of buying a mainframe or a server or large storage facility to store your data, all these things, mainframes and storage items, are dubbed as infrastructure in the IT world. And so instead of buying all of this infrastructure, hardware, just store it somewhere in a data center provided by a reliable company. And so instead of storing your data on your own machines, you are just storing them online. And this business, as of 2011, was booming and still up till today. in many cases, this is helpful to business activities because now you can access your information and data anywhere in the world. So if you have a Salesforce person and you store the data of your customer relationship in this website by a big company called Salesforce, your employees can access this anywhere. And now some companies, especially like Apple and Google, and Amazon and others, they discovered something. Now that we have your data, we can do more. If you allow us to, through privacy agreement and stuff like that, to analyze some of this data. And so they came up with the idea of offering you services to help you with the data. The first one, or the first few, was make sure that the data is secure, and make sure that you provide access to other people, and track the usage levels and who accessed what. And this led also to a new model that is beyond just storing the data. Can we serve the software? In the old days, if you wanted to have an email, you used to have to buy and install a software such as Outlook, with all the settings that you need to have, with all the bugs that could exist, and not so easy access to it. Right now, everybody has a Gmail, and you have no relationship to the software behind Gmail. It is fixed by Google, it's updated by Google, it is secured by Google. All what you need is just to access that service. So the software is not a code that you download anymore, it's a web service that you access online. One example of this is a variety of software systems that you can subscribe to with companies. So for example, a company could offer its employees a web-based access to a variety of software, much like Microsoft Excel and Office 365, and an employee can access all these software through a website by the company, instead of that employee having to download things and install them on the computer, keep updating them, keep working on the storage capacity and the problems. You just provide your employees with access to the software through an online system. With that, you can also, as an employer, track trends and performances and see what are the usage levels and what are the issues that could be changed. Security is also enhanced. People believe if you put your data on the cloud, that's not going to be secure. Well, it's actually more secure in a variety of ways, because these companies tend to have much more stronger IT abilities and much stronger ability to respond to attacks than say a small company that is not related to IT or doesn't work in the domain. Now this is no full guarantee, because Yahoo and others had big hacks. So now that we have your data and you can access it through a web, we can provide a variety of services to you. Take for example the automation of business processes in a telecommunication company. In these companies, a customer can call to complain about an issue or discuss an issue. The employee in the call center already gets an access to the information about the customer, their loyalty, their profile. They can address the problem, and if they see that there is an action that needs to be done, they click on a tab. This tab would send an information to the construction group and say, well, the cable serving this person is cut. The construction group software can show them the availability of crews and timing. By sending a message to that other software, the employee or the call center person can get to tell you when exactly is the construction or installation going to happen. At the same time, if you order a new service and you agree on starting it next month. By click of a button, the same information that you agreed to goes to the accounting department, which again goes to the account receivables department and becomes an automated withdrawal system from your bank account. That is the essence of process automation. It's a sequence of processes that are reliant on passing of data, and at the same time, its complicated software analytics is hidden from the employee. All what you see is what you want for conducting your work. Netflix is one of these companies which allows you to do similar things, and more importantly, their software helps detect your patterns and suggest new services for you. And so the software right now becomes something that you ask to serve. In previous years, it was typically a headache and not connected to business processes. Now, with the advancement of crowdsourcing and the technical agency of today's generations, companies started to say, well, instead of just offering a software to serve people, we will offer a software system that would allow innovators and tech-savvy people to come up with a new application that we never thought about before. This is called platform as a service, whereby big companies like Apple, Google, and Salesforce have a developer side of their website. There they find the most basic ingredients for software development, easily used, and all what this person has to program is the service side of things. And once they do that, they have the opportunity to post it online and get some money for that. So there are basically three types of cloud computing: the infrastructure as a service, the software as a service, and the platform as a service. And here is some examples of their usage by different players in the organization. If you look at some of the results of using platform as a service, you can see here that Salesforce has succeeded in getting at this time 1 million people to use its application. If they make couple bucks out of that, that would be a good income. But more importantly, these apps are mostly developed by other people, and so here you can find a variety of apps that you can use. So this is, for example, one of them is a workflow driven project management software, which is a software developed by a small company or a group of developers to help you track project activities along with your customer relations. There is another project management tool which is available easily for download to manage your projects. Now this brings the importance of business process modeling into informatics. Business process modeling is a very important part of realizing an informatics system, because informatics is a collection of code, which is the easiest part, that matches an automated process, which is now also becoming easy to serve people in their needs, and this is becoming the big challenge right now. More than serving people, informatics is trying to encourage people to generate knowledge and share it, and this is again one of the biggest challenges. So you need to automate the processes, and for that you need to model them and link them to software and make the software easily accessible. So if you want to use software as a service, the first thing that you need to do is to have a business analyst who would look at what are the problems that you have, what are the tasks that you do, and what data you need, and then this will be matched with the available software that you can have. And so you have two fundamental diagrams here: the logical diagram of the business process and the data flow diagram, and they have to be matched together. So here is a transaction for ordering something, and as you can see, there is a listing of the processes and their relationships and the information that needs to be collected. At the same time, if you have different set of processes, once you model them, you have to make sure that there is a linkage between the two processes, and in many cases that linkage is hard because one process will have a data standard that is different from another data standard. So here is in this example the catalog number that is listed to be seen by users and to order a new product online is not related to the material number that is needed to produce it. And so there must be a link, a bridge, a data standard schema that would link the two to each other, and here it's called catalog to material that would allow the two to exchange. In all of this, you have a flow of work aligned with a flow of data, and in this regard you have a facility and several tools that would allow you to work on this. In many cases the same tool, the same software would allow you to draft the process flow and list the data flows, and some of them are very smart to detect problems and issues between them. There are a variety of the business modeling languages which are standardized, and basically they tend to end up with several basic notations. Is that they have different tracks, and this track could be like dedicated to the finance department, to the accounting department, or a track could be related to value proposition or part of the work of a company, or a track could be a person. In between these tracks there are processes that are linked through a logic. A variety of these has existed throughout the years, starting from the 1980s with basic workflow systems, throughout business process modeling in 2000, and this was complemented by the service-oriented architecture. And as you can see, there is two fundamental tracks, which is the workflow system, and that would capture your workflow, but on the other side there is a process definition which defines what is required for every process and the activities in addition to the data. By linking the two, you can automate your process. Now within this there is a variety of tools and standards that exist for you to put a representation that is more sophisticated. So you can define that there is an actor who has access to the data, but this actor could be an agent who have control over the data, and each of them has a role and a position. And you could also add some rules: who will access what, who will provide what data, what message should be sent to who if this action is done. As you can see, eventually to build service-oriented architecture, you first have to integrate in the lower layer here the old systems that you have. You don't abandon them, but you have in the middle to orchestrate the services: who will put what data, who will receive what data, and what kind of algorithm is going to be used to create the results. And at the end you compose for every user the apps, the services that they need. Again, you look at the business as a logic flow of data and processes with rules on top of them. And in addition to that, these languages are now advanced that would allow you to drag and drop a repeated process into your flow. So for example, the online ordering process or the charging process, there are a variety of them that is already made, and when you are building your organization logic, you can just drag and drop into your system. Also, you have rules for emergencies, or rules for what to do when situations happen, and this is becoming very important. Here, this software allows you to define which process you want to put a rule for and what kind of rule do you want to have to this process. The ultimate result out of this is that you can also, in addition of serving your employees, you can track what is going on. How many times did a customer call and this customer waited for more than 5 minutes? How many times did a process of serving a customer yielded dissatisfied customers? How many times did this employee talk to this employee and they found a problem between them? How many times did we offer this service to the customer and it received appreciation from them? That is also can allow, for example, your salesperson, while they are talking to a customer to buy thing, they can show them statistics and information about what is going on, the average sale prices, the average benefits from something. Everything now is provided to them on their laptops. So eventually you have 3 layers when you build software as a service. The lower layer is the infrastructure layer, where you store the data and you have your hardware. That could be either physical hardware or on the cloud. In the middle there is a platform layer. Now this platform, when it's used by a big company, it's internal platform, and the need for this platform is for your sophisticated IT personnel to establish apps that would take from the data what serves the end users. Now for companies like Apple and Google, this platform is open to everyone, which allows people to create whatever apps they want. Once this platform, managed by your business analysts, by your IT department, is used, then they can serve data and access and process automation to your customers. And this allows you to have access to whatever you want. But this creates new roles and functions that you can see in terms of the operation and the management, who have access, who have role, and the whole issue of governance of data flow. There are a variety of sub categories and subdomains that comes out of the software as a service mentality, from the service-oriented architecture, models and tools and concepts that would allow you to build an architecture for your software to become oriented towards service, not like the old way, or to a different level, software as a self-service, where it allows you to give users access to the platform to change what the software is providing them. The big players are all in this domain, and it's increasing from Google to Salesforce to even companies like Adobe, which is trying to get into that market, for example. Now, all of that has created a new form of enterprise. There is no governance schema for data. There is no roles for management to control the flow of processes and the data to them. And what we have right now is an organization that is layered around data. And the good thing about it also is that these parts could exist in different places. But as you can see, there is a strategy level, people who develop the products and define what kind of changes in the process of managing things are going to change. There is a design department that design the services and the products, and there is a department that includes the accountant that would optimize the services and study the markets. There is a control department that would look at the performance, and there is reconfiguration of services based on data and negotiation between customers and the company. All of that is related to fundamentally 3 things: process automation, data flows, and the innovative employee. Here is a sense of how innovative employees' experiences can be harnessed. the field of social network analysis, which is not only limited to social media analysis. Many companies track the relationships between their employees and their exchange of data to understand who is participating into an information bottleneck or something like that. It is available, such analysis, if you collect this data, to help with everything, particularly the marketing, but there are some services that are related to services, strategy, and delivery. Now, crowdsourcing became a business tool, whether it's outside or inside, and we talked before about the Netflix prize to get enhancement to its algorithm. We also talked about the Gold Corp crowdsourcing regular people to look for gold in their mines. This is a nice chart. It's a bit crowded, but it shows you the crowdsourcing landscape, which companies are working where. So some companies are interested into creating a service marketplace, which would allow you to establish a crowdsourcing website. Some to the right, as you can see here, is related to just idea generation and management. Some are related to getting users to help predict issues. Some are related to crowdfunding. Some are related to the softer issues of automating the crowd processes and so forth. Now, when it comes to these types of business models, you can find a set of types in this regard. For example, here you see a business model for a company that just establishes platform. Now, this company here has a business model that relates to building crowd management and breach processes. This company is related more to content management in the processes, and this company could assume the role of marketplace for crowd.